Hey guys, in this video I'm going to walk you through how to answer questions related to material requirements planning. First question is about MRP, identifying bill of materials without considering lead time. Question 1 has two sub-questions. First is that you need to draw the product structure tree. Second, you need to identify how many units of each component are required in order to produce 100 final products. To show the bill of materials, you need to draw the product structure tree like this based on this given information. Product tree presents how a product is put together. It contains the information to identify each item and the quantity used per unit of the item of which it is a part. So in this question, final product M is made of 2 units of N, 2 units of N, and 3 units of P, 3 units of P. At the first level, subcomponents N consists of 2 units of R, 2 units of R, and 4 units of S. At the second level, components R is comprised of 1 unit of S and 3 units of T. At the first level, subcomponents P is made of 2 units of T and 4 units of U. So this BOM structure has 3 levels of components to produce a final product M. This is the bill of materials to make a product M. Second, we need to calculate how many units of each component are required to produce 100 final product M. We can calculate quantities of each component by simple multiplication. To produce 100 M products, we need 2 units of N, 2 units of component M, which is 100 times 2 equal 200. To produce 100 M products, we also need 3 units of component P, which is 100 multiplied 3 equal 300. Next, in order to produce 200 components N, we need 2 units of R, 2 units of component R, which is 200 multiply 2 equal 400. Next, component S is utilized to make subcomponents N as well as subcomponents R. So we can calculate S is equal 4 times N components, number of components, plus 1 times number of components R, which is 4 times 200 plus 1 times 400 equal 1200. Next, also component T is utilized to produce subcomponents P as well as subcomponents R. So we can calculate T components is equal 2 times number of components P plus 3 times the number of components R, which is 2 times 300 plus 3 times 400. So we need 1800 components T. Next, to produce 300 components P, we need 4 units of components U, which is 4 times 300 equal 1200. Let's move on to next question. Question number 2 is also pretty much like question number 1. Based on this information, you can draw the BOM tree like question number 1. After drawing BOM product structure tree, then you need to calculate how many units of each component are required to produce 100 final products A. Based on this given information, I draw BOM product structure tree for you here. Product A is consists of 2 units of B, subassembly B, 3 units of C, and 1 unit of D. B is composed of 3 units of E and 4 units of F, and C is made of 2 units of H and 3 units of D. Component H is made of 4 units of E and 2 units of G. In this question, we also have 3 levels of product tree. So to produce 100 units of A, we have to determine the number of units of B, C, D, E, F, G, and H are required. Like question number 1, we can calculate quantities of each component by simple multiplication. So to produce 108 products, we need 2 units of B. 2 units of B, which is 100 times 2 equal 200. To produce 108 products, we also need 3 units of C. 3 units of C, which is 100 multiply 3 equal 300. Next component D is utilized to make product A as well as a subcomponent C. So we can calculate D is equal 1 times the number of product A plus 3 times the number of components C, which is 1 times 100 plus 3 times 300 equal 1000. Next, in order to produce H component, we need 2 units of component C, 2 units of component C, 2 units of component C, which is 2 times 300 equals 600. Next, component E is also utilized to produce subcomponent B as well as subcomponent H. So we can calculate the E component is equal 3 times the number of component B plus 4 times the number of component H, which is 3 times 200 plus 4 times 600 equal 3000. Next, to produce 200 components B, we need 4 units of components F, which is 4 times 200 equal 800. Finally, to produce 600 components H, we need 2 units of component G. 2 units of component G, which is 2 times 600 equal 1200. That's it. Let's move on to next question.